How many do you think there are of these?
Well, like of just this example?
Yeah. With one train car.
Well, assuming that I think there's only 2, because you have to have exactly one of them.
I think I can see something different.
Okay, what do you see now?
So, you could, in this, you could replace it with this.
Oh.
You can replace it with this, and so on.
And are they all different?
Yeah, they're all different.
Interesting.
So, it might not be as simple, because then now we can replace the cars.
Ah, okay.
So there turns out to be a lot more than we thought.
Yeah. But that's all right. Does it change when your answer when it's just the front and the back, the engine and the caboose?
No,
because there's only one engine.
There's
and
nothing
one
to
caboose.
replace.
Okay. What about when there's one car? How do you have to change your answer?
Then you have to multiply your answer by 10. And you can
Okay.
replace it. You can replace it with 10 different things.
All right, so instead of 1 factorial times 2, it's actually 1 factorial times 2 times 10.
No, isn't it times 9? Because you're using 1 here.
Oh, good question.
Well,
2.
you have 10 things.
But you're using 1 already. So you can only replace it with 9 things.
Yeah, but if you have 9, if you multiply it by 9, that's only 9 ways.
So how many cars with just exactly one car can you make here? How many trains with an engine, a caboose, and one car can you make?
So you can make this way, and then there's 9 other ways you can do it.
Okay.
And you flip it.
All right, so how many total is
That
that?
would be 20.
Okay, so 1 factorial, because you don't, times 2 times 10.
Yeah.
Okay. Now what if you had to make 2
So
cars on it?
so now
What
it's
what do you
a
have to
little
do
more
now?
complicated.
You can replace, let's say, this one with you have 9 choices for what you do with this one.
Uh-huh.
And then you have, well, actually you'd have 10 choices for what you put here and 9 choices for what you put here.
Okay.
So that means you have to multiply your answer by 90, and we're assuming that order doesn't matter here.
Well, order does matter because you
Well,
have to.
yeah, order does matter here.
Okay.
It's like this would be kind of different as that.
All right, so how do you want to count this? Because before we were saying, you said it was 2 factorial times 2. So how do you want to count it now?
Well, it's 2 factorial times, would it be times 90 times 2?
Well, what do you think?
Because
What does the 2 factorial represent?
Well, it's the number of, well, that's the number of ways you can put them. You can put 2 cars down.
Show it to me.
Like, this way
Okay.
and that way.
All right, so if we want to keep that 2 factorial, what should we
So-
multiply by?
Then we have to multiply by 45.
Why?
Because, well, then we maybe shouldn't keep the 2 factorial, since we're already counting that over again.
Okay, so how do you want to count it here?
Well, I think it'd be 10 times 9 times 2.
Okay, so you want to call it 10 times 9 times 2. Okay. What about for 3 cars?
3 cars.
Because previously you told me it was 3 factorial times 2.
Well, now it's 10 times 9 times 8 times 2.
Ah, okay. So we're getting rid of our factorials.
Yeah.
All right, and then what's it going to be at the end?
So, are you mean for 10 cars?
Yeah, for 10 cars.
So it would be 10 factorial times 2.
10 factorial times 2. Okay, cool. All right, leave it there with 3 for a second, and we'll do this for the last video.